will be talking about solving equations with rational exponents and inequalities. The first two examples I have lead off from where we left off last class period. We're going to solve for x. So we do order of operations in inverse order. So the first thing that you need to do to both sides of this first equation is subtract 2. Now when we do so, those are inverses, so they will cancel each other out, and we're left with 2x to the 3/4 power. Now, be careful, you don't need to distribute that 3/4 power because we're going to get rid of it by using its multiplicative inverse. The multiplicative inverse of 3/4 is 4/3. So we're going to multiply both sides by 4/3. When we do so, the parentheses on the left-hand side will fall out and we'll be left with 2x. Now, if you look at your exponent table, it says the cube root of 8 is 2, and 2 to the 4th is 16. So 8 to the 4/3 is 16. Now I divide both sides by 2, and I get x equals 8. Now, just like before, with radicals, we need to check for extraneous solutions. So what we need to do is take our calculators or our brains, and we're going to substitute in 8 for our answer. So 2 times 8 to the 3/4 plus 2. The goal is to get 10. Well, 2 times 8 is 16. The 4th root of 16 is 2. 2 to the 3rd is 8. And if I add 2, I get 10. So that checks out. So 8 is my solution. Let's try another one. Now on this one, I don't have a number behind or in front of my parentheses, so I can go directly to taking both sides to the reciprocal power. The reciprocal of 1/2 is 2, so I'm going to take both sides to the second power. When I do so, the parentheses fall out and the term falls out on the left, leaving me x plus 30 equals x squared. Now, since I have an x squared, an x, and a 30, we know that we have to move everything to one side and set it equal to 0 so we can solve it. Now, since x squared is positive on the right, I'm going to move everything to the right-hand side. So I'm going to subtract over my x, and I'm going to subtract over my 30. X minus x is 0. 30 minus 30 is 0, leaving me 0 on the left, is equal to x squared minus x minus 30. Now we need to solve the trinomial. So we have a couple different methods. Well, actually 3. We could complete the square, we could use the quadratic formula, or we could factor. The easiest of which is factoring if there are factors of the last that give you the middle term. Well, the last term is 30. Factors of 30 that give me -1 are -6 and +5. Now, if I couldn't find factors, then of course I would need to use the quadratic formula to complete the square. If I set each of those intercepts or zeros equal to 0 and solve, I get x equals 6 and -5. Now, just like before, I need to check both of my answers. So I'm going to do so at this time. First number being 6. So 6 plus 30 to the 1/2. Well, 6 plus 30 is 36. 36 to the 1/2 power is 30. The square root of 36, which is 2. Well, I wasn't supposed to get 2. I was supposed to get 6 because it says x up on the right-hand side. So 6 does not work. Let's try the other one. -5 plus 30 is 25. 25 raised to the 1/2 is positive or negative, or is 5. And does that equal -5? Well, it does not. Actually, I have a typo. If you just realize that, or right up, this should have equaled 6. 6 plus 30 is 36, which is 6. So that one actually did work. but the negative 5 does not work. Sorry, people make errors. Let's try another one. X plus 6 to the 1/2 equals x. So this is kind of like just like the last one we did. So we're going to take both sides to the reciprocal power. So 2. So x plus 6 equals x squared. Move everything to one side. You get 0 equals x squared minus x minus 6. Factors of 6 that give me -1 would be x minus 3 and x plus 2. If I set those both equal to 0, I get 3 and -2. Just like before, hopefully I won't screw it up this time, we're going to substitute in my numbers. So we're going to do 3. Is 3 plus 6, that's 9. The 1/2 power, that's the square root. So the square root of minus 3 equal to 3. Yes, it is. So the 3 works. Let's try the -2. -2 plus 6 is 4. 4 to the 1/2 is 2. But I was supposed to get a -2, so that does not work. So -2 is what we call an extraneous solution. Next one. X plus 2 to the 3/4. Step 1, take both sides to the 4/3 power. So we get x plus 2 equals cube root of 8 is 2, and 2 to the 4th is 16. Subtract 2. We get x equals 14. I check this. It's 14 plus 2, which is 16, to the 3/4. The 4th root is 16 is 2, 2 to the 3rd is 8, and it says it should equal 8, so that one is working. So that is how we solve with rational exponents. Now what we're going to do is we're going to solve radical inequalities, which can be the same thing done as rational inequalities. Now the book shows a graphing method where you use a graphing calculator to check your answers, but we're going to just use a number line. So the first step whenever I'm counting through these problems is I just imagine or I change my inequality symbol to an equal to sign. Now you can use your inequality rules and solve it like that, that's fine. And I'm just going to use my basic rules. So I divide both sides by 3. I get x minus 1 equals 4. I square both sides. I get x minus 1 equals 16. So if I add 1 over, I get x equals 17. So what I'm going to do is I'm going to put 17 on my number line. Now, there is something we haven't really looked at before that we do have to look at here. That's what's called domain restrictions. Now, we could say that x could be everything but 17 or everything with 17, but we have a problem with that. Because if you look, you're taking the square root of x minus 1. And if x was a negative number, what would happen is we'd have a square root of negative, which would yield an imaginary solution, and we don't want imaginary solutions. So in addition to finding the x value, you need to set the inside of the radical, whatever it is an even root, equal to, to be greater than 0, because you don't want to take the square root of a negative. So if I add 1 over, I get x is greater than 1. So my other boundary is going to be 1. Now I know from this statement right here that x has to be greater than 1. It could be equal to 1 because you could have the square root of 0, which is 0. So at 1, I'm going to fill in a closed coordinate. Now, I got 17 as a solution, and that's supposedly a filled-in coordinate as well. So all I need to do now is figure out which way my graph is going. Now, this may come in 1, 2, or 3 parts. So what we're going to do is we're going to check different values. So I'm going to check 0 first. If I check 0, 0 minus 1 is negative 1. Square root of negative 1 is I. Can't have I. So 0 is false. I'm going to check something in between the two. Say we check 15. 15 minus 1 is 14. The square root of 14 is a decimal. If I take my calculator, the square root of 14 is 3.7. And if I multiply that by the 3 in front, I get 11.22, which is still less than 12. So the 15 is true. So now I'm going to pick something larger than 17. Maybe I'll pick 20. So 20 minus 1 is 19. Square root of 19 is 4.3. 4.3 times 3 is 13.07, which is bigger than 12. So that one's false as well. So my solution is in between the two. So my solution to this math problem is 1 is less than or equal to x, which is less than or equal to 17. Let's try another one. 2 cubed root of x minus 3 has to be greater than or equal to 3. So we add 3 to both sides. So I get 2 cubed root of x. I'm going to imagine it's an equal to sign is equal to 6. I divide both sides by 2. I get cube root of x equals 3. And then I cube both sides. 3 to the third is 27. So I'm going to put 27 on my number line. It says greater than or equal to, so it's going to fill in coordinate. Now you have to figure out if I have any domain restrictions. Now here, instead of taking a square root, we're doing a cube root. And if you remember, odd roots, we can take the root of a positive or a negative number. So we don't have to worry about imaginary solutions on this one. Since we don't have to worry about imaginary solutions, we only have 27 to work with. So then I pick a value. Maybe I'll pick 0. Is 2 times the cube root of 0. Well, the cube root of 0 is 0. So 2 times 0 is 0. Minus 3 is negative 3. Is that greater than 3? No, it's not. So this is false. Pick something bigger. Now I'm going to pick something I can actually take the cube root of, so I'm going to take 64. Because the cube root of 64 on our exponent tables is 4. So 2 times 4 is 8, minus 3 is 5. 5 is greater than 3, so that is true. So this time, we're going to have an array that goes to the right. So our final solution is the following. X is greater than or equal to 27. We're almost done. We only have one more example to do. Now this one looks kind of funny because when I took a picture of it, there's a little slash after the 8. It doesn't really exist there. I did pick another even root for those of you who are struggling with that. So the first step we're going to do is divide both sides by 4. I get the fourth root of x plus 1 is less than 2. I say, okay, what is the opposite of a fourth root? That's a fourth power. So I'm going to take both sides to the fourth power. I get x plus 1 is less than, or you could just put an equal to sign, 2 to the fourth, which is 16. Subtract 1 over, I get x. I'll just put an equal to sign for the sake of it, so I'm not freaking you out. It's 15. So I'm going to do 15. Now that is an open coordinate because it does not say equal to. I'm going to set what's inside my radical, it's called my radicand, such that it's greater than or equal to 0. Subtract 1, I get x has to be greater than or equal to negative 1. So I'm going to put negative 1. I'm going to put a closed coordinate. Now I'm going to pick some points. I'm almost done. If I pick, say, 0 in between the two. 0 plus 1 is 1. Fourth root of 1 is 1. 4 times 1 is 4, which is less than 8. That is true. Okay, what about pick something bigger? Say 20. 20 plus 1 is 21. 21 to the 4th root is 2.14 times 4 is 8.5, which is bigger than 8, so that is false. So now I'm going to pick something smaller, say negative 10. Negative 10 plus 1 is negative 9, but I can't take an even root of a negative number, so that is automatically false. So my solution is x is in the middle. It can be greater than or equal to, but it needs to be less than 15. So I hope this is helpful in completing your assignment for the day.